Welcome everyone, hope you're doing well. We are in Unit 6 now, all right? Unit 6 is about similarity, and so what we're gonna be doing is talking about dilations today, okay? So you should have done a Desmos activity, all right, that taught you some stuff about dilations. So literally anything you learn about dilations, you can write there. I'm not gonna write that down, that's for you. What I am gonna do is we're gonna kind of go through some stuff about dilations. So dilations are a type of non-rigid transformation. Oh wait, never mind. The word transformation is already there. It's a non-rigid transformation. So what that means is that the shape grows in size. Okay, if you remember back to our transformations unit, we talked about rigid transformations, rotations, reflections, and translations. Non-rigid transformation is a dilation. Okay, so a dilation actually changes the size of the pre-image. And the way that we measure how much it's changing in size is with the scale factor. Okay, so the scale factor measures how much larger or smaller the image is. So you might have heard that word before, scale factor, but that's something that we're going to be talking about here. So if a scale factor bigger than 1 means that your image will be bigger than your pre-image, all right? So you can see over here, this would be a scale factor greater than 1, the pre-image grows. And we called that an enlargement, all right? If you remember from Desmos. A scale factor less than 1 means your image will be smaller. All right, so this would be like a fraction, not necessarily a negative number, like a half or a third. All right, so you can see this would be what we call a reduction. So we've got enlargements and reduction. So enlargement is bigger, reduction is smaller, and that's all based on the scale factor, okay? So you also learn about the center of dilations, all right? We're always gonna be looking at dilations centered at the origin for this class, just because that's a little bit easier to do. So we're gonna go through a couple questions here. So question 1, which figure is the pre-image and which is the image, okay? And how can you tell? So this is kind of a little bit of review back from our transformations unit, but the pre-image and the image, right? Which is which? Remember, the pre-image is obviously first, so the image is after the transformation. And if you remember, after you do a transformation, that's where we add the primes. Remember, we call that C prime, all right, compared to just C right there, or we look down here, we've got A and A prime. So the image will always have the primes. So the pre-image is triangle ABC, and the image then would be triangle A prime, B prime, C prime, okay? So it's all based on the primes. So if you're looking at a picture and it says, what do you think the scale factor is between the two figures, you have to know what you're starting with and what you're ending with, right? So for this one, we're clearly getting bigger, right? The pink is the pre-image, the blue is the image, so it's getting bigger, all right? And so how can we tell how much bigger, all right? And it's all based on the coordinates, all right? And it's all based on multiplication, okay? So for example, look up here at the A, B, and C, and then look down here at A prime, B prime, C prime, okay? A is -2, -2, A prime is -4, -4. So how did they change, right? They're being multiplied by 2, right? Same with B. B is 1, -1. B prime is 2, -2. It's been multiplied by 2. C is 0, 2, and C prime 0, 4, right? It's been multiplied by 2. So that means the scale factor, all right, is going to be 2. So in general, for a dilation with a scale factor of K, this is all you do is multiply each coordinate by K. So x, y, the point, would turn into k times x and k times y. So dilations, I think, are really easy to do. You're just multiplying the coordinates by a number, okay? So we're going to look at an example here. Quadrilateral ABCD, okay, so we need to plot these points, has vertices at A. So A is at -2, -1, so that's left 2 and down 1. B is at -2, 1, so over 2, up 1. C is at 2, 1. And D is at 1, -1. So we can make our quadrilateral. Forgot to label that D. Quadrilateral just means it has 4 sides. Okay. So on the coordinate plane, then find the coordinates of the image for the dilation with a scale factor of 2. Okay. So we're going to go through these real quick. All right. And I'm actually going to write these out, but you don't necessarily need to write them out when you are doing it yourself, like when you're on your practice, but you can if you want, if you think it's helpful, okay? So if you actually write these out, so all we're doing is we're multiplying each number in the coordinate by 2, all right? So A prime, we've got -2, -1, so that's going to become -4, -2. B prime, that's going to become -4, 2. C prime is going to become 4, 2. And D prime is going to become 2, -2. All right, so now we just need to plot the new points. So A prime, -4, I'm going to do this in a different color. Let's do this in orange. -4, -2, so there's A prime. B is at -4, 2, or sorry, B prime. C prime is at 4, 2. And D is at 2, -2. And so if we connect them, we now have performed a dilation. All right? We can see that it's clearly bigger. All the side lengths have grown by 2. So that's how you do a dilation. All right, so we're going to look at 2 more examples, and then we'll be done. They're pretty much just doing the same things. All right, so let's do this one, triangle FOR. So F is at -3, -3. O is at 3, 3. And R is at 0, -3. Okay. Then it says dilate using a scale factor of 1/3. Okay, so this one's a little bit different, okay, because this one's actually a reduction, right? 1/3, it's going to be getting smaller. So yes, we're still going to be doing the same thing. We're still multiplying by 1/3, but instead of multiplying by 1/3, you can also think of that as dividing by 3, right? Multiplying by 1/3, dividing by 3 is the same thing. So if we want to list our points, F prime, if we divide those by 3, -3 divided by 3 is -1. So that'll be -1, -1. 3 divided by 3 is 1. So this is going to be 1, 1. And then R prime, so 0 divided by 3 is still 0, all right? And -3 divided by 3 is -1. So our new shape will be at these points. We've got -1, -1. We've got 1, 1, and we've got 0, -1. So this one's clearly much smaller, right? All right, so there's our new shape. So that's how you do a dilation. That is a reduction, okay? So the last one, I actually want you guys to try by yourself. Okay, I want you to write out the points, see if you can perform the dilation. So pause this video and try it, and then when you're done, you can check the answer. Okay, So I'm going to do this real quick. So I'm just going to go through the points. So we've got t at -1, 0. H is at 1, 0. I is at 2, -2. And S is at -2, -2. So this should have been what you got originally. What you're doing from here, all right, is multiplying all your coordinates by 3. So I'm not actually going to write it to the side. This one's over 1 from the origin, so we know it's going to end up being over 3. So there's t prime. Similar, h is 1 to the right, so we're going to go 1 to the left for h prime. Now, s is over 2 down 2. So if we want to multiply that by 3, we've got to go over 6 down 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's s prime. And then I, same thing, over 2, or sorry, it's over 2 down 2 to the right. So we're going to go over 6. 1, 2, 3, 4, 5, 6, and then down 6. 1, 2, 3, 4, 5, 6. And there's I prime. And so this is our new shape. This is what you guys should have got. So notice it's a lot bigger, all right? Dilations work quickly, If every single side is multiplied by 3, that's significant. It makes the shape a lot bigger. So this is dilations. Go ahead and try the practice, all right? It's pretty much just similar to what we did here. If you have any questions, let me know, and have a great day.